Hello friends, welcome to my channel. This is the first video in the series about the project I'm currently working on. I'm going to build 6 degree of freedom robotic arm. It will be mostly 3D printed. Today's video will be devoted to the assembly of the grip arm. I've already 3D printed all the necessary parts, so without further ado, let's get started. I'll begin the assembly with mounting of the actuator to this yellow base. This is the actuator, it's a Dynamixel AX12A servo motor. I've mounted 3D printed input gear on it. Here we have embedded nuts to fix the motor, and it will be fixed over here. Now I'll take M2 screws and secure it properly. Like so. Next goes this little part, which I'm going to place here, and the same exact part comes in front of it. This big part has some bearings mounted on it, and the purpose of these bearings is to facilitate the movement of this black rack, which will carry one of the fingers of the gripper. Also, here we have embedded nuts, and this is MPU 6050 gyroscope and accelerometer. And this part goes here. This black part will fix everything together. Besides, it will prevent rack from moving sideways. But before, I'd like to explain you where these two wires come from. This black thing that I stuck to our 3D printed part is a sensor that reacts at contact. It's a resistor which changes its resistance when it is squeezed or bended. And now I'm going to show you how to make such a sensor. First you take a wire. You can stick everything to the piece of adhesive tape, like scotch for example. Then goes a piece of aluminum or copper foil. It's needed to increase the surface of contact. And then goes the piece of velostat. It's a material which changes its resistance, conductive material which changes its resistance when force is applied to it. Then goes another piece of aluminum foil and a wire. And to fix the whole sandwich, we can use another piece of scotch. To fix this sensor to the place where I want it to be, usually I use another adhesive tape. This time it's double-sided adhesive silicone tape. One more piece of adhesive tape. And the cherry on the cake, another tape. This time it's a foamed rubber. All these layers aim to make the whole sandwich flexible and springy. Okay, now I'm going to show you quickly how the sensor works. You can't measure resistance with Arduino, but you can make voltage divider circuit and measure voltage drop. And I made such a circuit, connected it to Arduino, and let's see what we got. Here you can see raw measurements of voltage. I didn't convert them to actual voltage because it's not important. The point is that when you press the sensor, these figures increase, and that's because resistance of the sensor decreases and the voltage across the second resistor increases, and we actually are measuring the voltage across the second resistor. And it's quite sensitive, it reacts even a slight touch. And I'm going to use this property to detect when the gripper is fully open, to stop the actuator, to avoid overloading, and to detect the contact with the fingers of the gripper. Let's get back to assembly. Here I'm fixing this new part with screws. And now I have to mount mirror counterparts of our newly installed components. This is the second rack, which will carry another finger of the gripper. As you can see, in final position rack pushes against pressure sensor that we made, and we will detect that to stop the actuator. Our gripper will be equipped with camera. For this purpose I'm going to use this ESP32 I-Thinker module. It has 2 megapixel camera and full flash microcontroller on board. And it's going to be inserted in these slots which I purposely designed. The wires should be passed through these holes in the gripper enclosure and routed outside. Like so. And so with the rest of the wires. Okay, camera module is in its place. All the wires are properly routed, and now our camera needs enclosure, which I'm going to mount next. But before I had to disassemble some of the parts, because I forgot to connect wires to this MPU6050 module. Also, I need to mount this plate with laser range sensor. With this sensor we are going to detect if the objects are close enough to be grabbed. And this sensor uses I2C protocol just like MPU6050. And both of them will be connected to ESP32. I designated some of the pins to serve as I2C bus. These are the wires connected to ESP32 pins, VCC pin, ground pin, and also 2 pins for I2C communication. Now I am mounting laser range sensor plate. The wires from this sensor should be passed through this hole in the base, and the plate itself is supposed to be mounted here. Alright, I've mounted back all the disassembled parts. Also I connected sensors with ESP32. We have some additional wires here. These green and red wires will go to the fingers on which tactile sensors will be located. And this red and white wire are for powering ESP32. Now we can get back to mounting camera enclosure. The whole module is supposed to be inserted in the enclosure like this. Okay. Now I am inserting it back into the slots. And now I have to secure the enclosure with the screws.
Okay, all is good, and it's time to mount the fingers of the gripper. This is one of the gripper fingers. It is divided into two parts, and these parts are supposed to be connected like so with the screws. Through these slots I'm going to pass the wires, and I will need these wires for tactile sensors, which I'm going to locate here, here, here. So there will be 3 of them, but they will act as a single unit. We won't be able to distinguish which one of them reacted to the contact. Okay, I've reprinted fingers, just changed their shape a little bit. All the rest remains the same. The wires are supposed to be inserted in these grooves like so. And secure it with the second part of the finger. And the same assembly procedure for the second finger. You already know how to make tactile sensor. For this you will need Velostat. It's not very expensive, you can buy it on eBay. Basically the sensor is just 2 wires and a piece of Velostat between them. The only problem to my mind is how to glue everything together. For this purpose I usually use adhesive tape, and also you should make sort of a springy cushion around the sensor, so that Velostat had some room to deform and so to change its resistance. The sensor is quite sensitive, it reacts even at slight impact. And the more you press, the greater resistance of Velostat changes. Though I don't know to what extent it will change, I think that it depends on the elasticity of the cushion around the sensor. If it's springy enough, I think it is possible to calibrate the sensor and to measure the actual force applied to it. And to add softness to surfaces of contact of gripper fingers, I lay down foamed rubber tape. Okay, everything is ready, and now I'm going to move on to the second finger. This is how gripper fingers look like now. I covered them with sort of a coating. I think they look better now. Here I made connectors, and this coating will protect the sensors. It will also improve adhesion of the fingers with different surfaces. Now I'm moving on to mounting the fingers, and the fingers, as you might have already guessed, are supposed to be mounted here. Alright, so far so good. Here you can see next portion of the wires coming out of the enclosure. Most of these wires come from tactile sensors. All these wires will be connected to this OpenCM board. It was designed to control dynamixels, and we will use it for its intended purpose. These three black wires are for communicating with our AX12A, but it's also a full-fledged microcontroller. It has analog inputs to which we will connect our tactile sensors. Now I have to pass the wires through these holes and connect this yellow part to the rest of the assembly. Alright, let's connect everything to the board. Tactile sensors have three wires. The first wire should be connected to some voltage source. We can use 5-volt pin on the OpenCM board for this purpose. The second wire needs to be connected to the ground. But since we cannot directly measure resistance of our sensor, the second wire is connected to the ground through small 48 ohm resistor. You can't see this resistor because it's on the heat shrink tubes. And the third wire is connected so to measure voltage across that resistor. And this wire should be connected to analog input on the OpenCM board. And that's what I'm doing now. Also I have to connect dynamixel. Some of the wires will be passed further through our robotic arm. Specifically, these are the wires for powering OpenCM, ESP32. Also we will need ground from OpenCM and serial receive and transmit. This will be needed to connect OpenCM to Arduino. Alright, finally we got to the last part of our assembly, this big yellow cover. I have to pass the wires through the hole in the center of the cover. Okay, finally we reached the finish. And now we can test how our gripper works. I've connected power to the gripper. Alright, actuator works okay. It closes and opens gripper. When the contact with the object is detected, actuator stops, and when the contact is lost, like so, for example, OpenCM board sends command to the dynamixel to open the grip. And I have to tell you that the grip is quite strong. can regulate the strength of the grip by regulating torque of dynamixel. Okay, I'm pretty happy with the result. Gripper works okay, it holds objects quite firmly, tactile sensors fulfill their function, and I can proceed with the rest of the arm.
Alright, that's it. This is the final result. Hope you liked the video and want to see more. If so, please subscribe, and see you next time. Bye bye.